everybody. Okay, so this video is about the vector product. So the scalar product is the one where you say you have vector dot vector gives you a scalar, right? So that's the scalar product, which the symbol is a dot. So that's why I call it a dot product. So now we're going to talk about the vector product. So vector product is vector times vector gives you another vector. And the symbol for the vector product is this cross, so then that's why we call it cross product. Okay, so if you already know the magnitude of the two vectors and you know the angle between them, so the smaller angle between them, not this one, then by definition the cross product is this magnitude times sine of the angle between them. But if you look at this is still a scalar, right? Because that's a magnitude, which is a scalar, that's a scalar, sine. So for the direction, some unit vector, according to the right-hand rule, which I will show you, okay, and it looks like I have a little bit off screen here. So according to the right-hand rule. So let's say you go A cross B looks like, here, let me situate myself. So you have to use your right hand. Let me zoom in here. So with your right hand, say you want A cross B. A cross B, and whichever way your thumb is going, that's according to the right-hand rule, the cross product. So for example, I cross J gives you K. So that's this picture, like this. I cross J gives you K. So you'll have to keep practicing using the right-hand rule until you get it, because it could just be like whatever orientation, right? So you have to just keep practicing. And at first, like literally use your hand to do it, not just in your head picturing it. Okay, so that's if you know the magnitude and then the angles. But let's say you know the vectors in terms of its components. So then the other way to do cross product is component by component. You write it as this determinant, like this. So you put the components of vector A here, the components of the second vector over here, like this. And then you compute this matrix determinant, and that's how you get the cross product. Okay, so how do you do that? There are two ways to compute this matrix determinant. So one way is called Cyrus Scheme, and it goes like this. And then you use whichever method is easier for you. Okay, so here's how it works. You copy the first two columns like this. Okay, and then you go this times this times this, and that's going to be positive, plus this times this, which is also positive, plus this times this, and then you go this way, this times this times this, and that's going to be negative. So then, and then this times this, negative, that times that, negative. Okay, so if you were to write this out, right, this one, it's like I hat AY BZ. Oh, I hat AY BZ. next, j hat az bx. J hat az bx. And then this one, k hat ax by, and then going this way now, minus j hat ax bz, and then this one minus I hat az by minus the last one, this one, k hat ay bx. Okay, so then that's, and you can gather terms, right? Like in the I direction, you can get these two, aybz minus azby, and then in the j direction, we got here and here, azbx minus axbz, and then in the k direction, where is it? This one and this one, axby minus aybx. Okay, so that's one way to do it. The other way is, cofactor expansion method. So it goes like this. You start with I, so you ignore this row and this column, and look at the leftovers here. So it's I times, and you multiply this like a fish, aybz minus azby. So let me write that. So in the I direction, just look at this and multiply like a fish, aybz minus azby. Okay, and then j, so you ignore this row and you ignore this column. What's left over is you multiply like a fish. But then here's the issue. With j, it's minus. So you gotta watch out, right? So minus j, and then these, like a fish, axbz minus azbx. And you can always multiply this in here. So instead you'll have azbx minus axbz, and then this will be a plus. Right, so just don't forget that minus sign, this minus sign right here. Okay, and then plus k hat, right, so ignore these. This is the leftover, multiply like a fish. Okay, so that's axby minus aybx. axby minus aybx. Okay, so, and then if you compare these two, it's the same. Right, so either way, whichever method you prefer, do that way. Okay, I'll see you in the next video. I'll do some more examples.